good morning, everyone. So please, before we start, get connected. So you go online, either you flash this QR code or you type wooclap.com, and when you are on wooclap.com, you type this. You can refuse the cookies. You don't have to accept them. And we will use that. So this morning, let me check the, okay. This morning I'm going to talk about a subject I've called astrobio washing. So it's a made-up word. It's based on a concept you may already have heard about, whitewashing or greenwashing. And, well, it's something that is related to that kind of examples you can read in the news, but first, before you can read it in your newspaper, in your news feed, on your smartphone, on your computer, most of the time it starts from a press release. And this is some recent example. It was a press release from ESO. It was published on March the 8th from this year. And yes, the name was Astronomers Discover Largest Molecule Yet in a Planet-Forming Disk. This is appealing. Wow, the largest molecule. But in a planet-forming disk. But if you're not a specialist, you say, yes, it's the largest molecule found. And okay, this is the introduction. They have detected a molecule called dimethyl ether. I think, yes, here it is, CH3OCH3. It's made of 9 atoms. And they say that it can be, but they don't explain how, it can be a precursor of larger molecules that can lead to the emergence of life. And the first lines of the press release is, from these results we can learn more about the origin of life on our planet and get a better idea of the potential for life in other planetary systems. So that's what they say. And okay, I was curious to learn more about what we can learn about the origin of life from the discovery of dimethyl ether. And I've been to the paper, because it's a good thing to read the news. Well, maybe it's a good thing to read press release, but you as scientists, you have to go to the source. You have to read the paper. And actually, when you read the paper, it's a very good paper about the detection of an interstellar molecule. There's nothing to say against that. But there's nothing about the origin of life in the paper. It's just the detection of a new molecule, not a new molecule necessarily, but a molecule in a specific environment. And in this specific environment, planet-forming disk, it's the largest one. But if you remember what I told you 2 days ago, well, this is the list of molecules we see in the interstellar medium. And dimethyl ether was already detected, but in other environments of the interstellar medium. And it's certainly not the largest molecule detected yet in the interstellar medium. But if you want to hit the news, you need, yes, to be the first, to be the largest, and of course, if you can add something about life, about aliens, about extraterrestrial life, yes, you're pretty sure to attract the attention. So, well, at least if it was glycolaldehyde, glyceraldehyde, you know the molecules I've talked to you about on Tuesday, these are the precursors of sugars. So then, yes, precursors of sugars, you can say it may tell something about the synthesis of ribose, desoxyribose. You can start to tell a story about the origin of life. But dimethyl ether is not that relevant. So you can say it's mild. I agree it's mild. You hear about science, you hear about space, people will maybe dream about extraterrestrial life, and maybe, and I'm among that kind of people, you start to get interested into science, listening and reading about those fantastic news about extraterrestrial life, especially if you are in the field of astrophysics. Probably a lot of us working in astrophysics, astrochemistry, we are fans of science fiction. But you have to pay attention. If you're a probiotic chemist, when you read that, you say, you roll your eyes, you say, oh, astrophysicists, they are so naive. They have detected a big molecule. I mean, nine atoms, and you say, okay, you don't pay attention. But it might harm the discipline of astrobiology, because if astrobiology is only carried by astrophysicists, and if you cut the community from the, I would call them hardcore organic chemists working in the laboratory, working on the synthesis of peptide, protein, working on the synthesis of nucleotide to get to RNA, DNA. If this community reads these news and says, these guys are thinking we learn something about the origin of life by discovering dimethyl ether, it's not serious. And they may not get involved into the astrobiological community. The only reason I can see to make this kind of announcement is to attract attention. And that's why I called it astrobio washing. So it's based on greenwashing, and Janet left, so I've put a Wikipedia definition on the screen. Because this is one example, but when you read the news, and I think once Google realized you're interested into that, if I read my Google feed every day, I get stuff like that. And these are some examples, and it looks like the question of life beyond Earth has already been settled. Methane on Mars, does it mean Curiosity rover has found life? Plumes from Saturn's moon Enceladus hint that it could support life. A gas found on Earth that signifies life has been detected in the cloud on Venus. And this is all over the news, all over the years. So, when I teach astrochemistry, astronomy, and when I do outreach, conferences, I use this tool. And so we are going to start to use it together. So just to train. Okay, that's not relevant to astrobiology, but I want to have your opinion. So you can start to vote. France. You have to go there. Don't you have a cell phone? Do. So you go to woclab.com and you enter this code. When I said everyone, I didn't mean only the students. I said everyone. Oh, I realized that I should not do that. Okay. Because you can see the results. So when I do the pool, I hide the results, but it's something I have to decide to configure. So, okay. So I'm not surprised. Thank you for supporters of Qatar and people supporting France. So, No. According to the most recent scientific paper dealing with that question, how many alien civilizations are right now in the... so don't vote. I have to hide that. Okay, and go. You can start. How many alien civilizations are right now in the Milky Way? So according, it was late last night when I prepared that, according to the most recent estimations. 1, 24, because you know 24 is the answer.
Did you put these possibilities here?
Sorry?
Are these your choices for the possibilities?
One of the results is actually the outcome of a paper.
Where is 0?
No, we are here. So
Well, we are here.
It says alien civilization.
Oh, yeah, yes, you are right. Yeah, yes. I should have said either. Yes, it's the first time I use this question, so it should be. I should have put 0, or I should have removed alien from the question. Yes. So consider when you answer, we are an alien civilization. That's what I meant. So only 16. I will see what you answer. Okay. Majority to we don't know. But it makes sense that with this audience we have that kind of answers. Because this is what you could read in June 2020. So what I will do, I start from the headlines. Sometimes I show you the press release and then we go to the paper and we see what is actually in the paper. And this was the headline. So I tried not to hit on a specific news company because it's everywhere. There is nothing that is worth somewhere. So there are at least 36 intelligent alien civilizations in our galaxy, says scientists. So that's what people will read. That's what will remain. Alien civilization news research says that 36 contactable alien civilizations likely to exist. Yes, it's likely here. Here there's no question mark. There may be more than 36 intelligent alien civilizations in the Milky Way, scientists says. There could be 36 community intelligent civilization, study says. So that was in the news everywhere. I have that kind of example in French, and probably I could not make a relevant research in Portuguese, in Brazil, but it's the same. And it's based on this paper. This paper is called and it's published in the Astrophysical Journal. And what I'm not complaining about this paper. I mean, as a scientist, I should be free. I should be allowed, as long as I put all the parameters, all the hypotheses. I am entitled, I am allowed to publish this paper. I get through peer review. I put all my hypotheses. It's discussed, it's published, it's okay. And actually, they say we find there should be at least 36 plus 155 minus 32 civilization in our galaxy. And how did they get there? They use the Drake formula. You know about the Drake formula, probably. Ask me question if you want me to get into details. And what they say in the paper, they say, we rederive a modern version of the Drake-like equation by first making the simple assumption that a sufficiently Earth-like planet in the habitable zone of a suitable stars which exist for a sufficiently long time, and they call that suitable planet, SP, will form life in a pattern similar to what occurred on Earth. Meaning, this term of the equation equal to 1, and they call it the astrobiological Copernican principle. And they assume that if a suitable planet remains in the circumstellar habitable zone for a time equal to the current age of the Earth, it will develop intelligent communicative life. The approach has the advantage of circumventing the need for Dweck equation quantitative such as this one, and this one. I mean, the values we have no clue about. The fraction of planets on which life actually appears, the fraction of life that gets to intelligent life, and the fraction of intelligent life that will develop a civilization. And so these are the current estimation of the terms of the Dweck equation, and actually these terms we have no idea. And applying what they call the astrobiological Copernican principle, they say, okay, let's assume this is 1, this is 1, this is 1. And when I say it could be between 0 and 1, we have actually no clue, no idea whether it is closer to 0 or closer to 1. We are sure that life appeared on Earth. We are working to know if it appeared somewhere else, but we don't know where to put the needle close to 1, in the middle, or close to 0. And it's actually an interesting paper. What they did after making those assumptions, they discuss the lifetime of a civilization, and they make a lot of sophisticated statistics. It's actually it's a science paper. There's nothing to complain about that. What is strange for me is that what remains is that. Another example, I go quickly through this one. We'll talk about Abraham Loeb later this morning, but these are papers called Galactic Panspermia, Astrophysical Journal Letters, or in the Astronomical Journal, Implication of Captured Interstellar Objects. That's a great thing. I mean, the fact that mechanistics, orbital studies says that objects can be ejected from a star, and some of them could be captured in the gravitational field of the sun, is really interesting, because it means that maybe we have comets that comes from an interstellar origin, and they were not built in our own solar system. It's not only dealing with interstellar objects that would pass by. It's dealing with the fact that some of the objects in the Oort cloud or in the Kuiper belt could have been captured by the sun, but they were formed around other stars. That's fascinating. I mean, yes, for me, working on small bodies, that's great. But Panspermia, we have no clue that there are any form of life out there, but they sell not only in the news, but in the papers themselves. They sell the fact that, not that it's interesting because we learn we have interstellar objects maybe in our own solar system. They say, oh, it's interesting because it might explain the origin of life. And then you get to the news. And, well, not only in the news, in science, in the outreach section of the Science Journal, you can read comet-like object could be spreading life from star to star throughout the Milky Way. Or on the City Institute website, comets and asteroids may be spreading life across the galaxy. But what, yes?
Why would it be easier to form some sort of life or organic molecules or something like that in a minor body in the outer solar system than in the Earth?
I have no idea. But that's the idea behind Panspermia. The root of Panspermia is that life comes from somewhere else. And it is spread throughout the universe by those kind of objects. And actually, Fred Hoyle was a very good astrophysicist. He made wonderful contribution to solar physics. But in the end, well, you know, he was a fierce opponent of the Big Bang theory, but he was also working on the Panspermia theory. And he had wrote papers about that. He was extremely, yes, he was promoting that idea, but yes, it's just pushing it forward. It doesn't tell you about the origin. It tells of the origin of life itself. It tells, okay, we don't have to worry about that. And people like Fred Hoyle, for instance, they were saying there is no origin to the universe. It was his idea. Idea. And on the same side, he's saying that there's no origin of life. Because if there's no origin of the universe, you can consider that there has been life all around for not the beginning of time, but for forever.
And also, we could have life, okay, if there is no origin, but we could have life, development of life in the Earth, and in some other place, and brought by comets, and you could have life being developed in two ways, for example. Or more than two ways.
Yeah. That's what it is. It's what is interesting. If we find another form of life, I hope it will be different than the one we know on Earth. Because if it's the same kind of life, yes, we could not exclude that there can have been some exchanges, but we are not at this stage. A while ago, I would say, okay, it's not such a big deal. Yes?
Very brief question. Are you suggesting that this kind of fake exaggerating news is only is more in astrobiology than other fields of astrophysics? Because the people have to produce news every day, everywhere, and they copy from each other.
I'm not saying that. I'm not sure. Probably there could be that kind of same trend in other areas, because actually we are also pushed to get money, to get funding. You are also pushed to make it to the headlines. Or universities or institutes, when they go to the Secretary of State of Science, they can say, oh, look, they talked about us in CNN or in Le Monde in France. So it's not necessarily just for astrobiology. I agree, but well, I'm talking about astrobiology, and I'm trying to follow that because, well, what starts to concern me is what I'm going to talk about now. Yes.
Right. It's about it's anything that grabs attention, because asteroids, you see, every week now we have a potentially hazardous asteroids that are coming from the sun that is very dangerous. Every week we have 2 or 3 of those. And they make the news. They go to the social networks, because that's how this thing works. Everything that grabs attention, they exaggerate and put something that's likable, something like that.
So these are my students, first-year students in my university. So the amphitheater is not that packed when I'm teaching, because this was only the first meeting. This picture was taken at the first at their arrival, and then I got them, but they are split into 2 amphitheaters, and first years, weeks after weeks, they tend to stop. But here is the kind of people I meet. They are 18, 19 years old. And when I start to teach them Introduction to Astrobiology, I use this feature, and I'm asking them this question. And before they answer, I tell them, I don't want you to answer what you think, what you believe. I want you to answer what you think is the state of the science about this question. So there are a few weeks within the semester. They're seeing me for the first time. And one of the first questions I ask is, there is life on Mars? Yes, it's proven. No, it's certain. We don't know. So please, answer. So I don't have too many answers. Okay. So two answers says yes, it's proven, and then I don't comment, and I say I change a little bit, and now there has been life on Mars. Yes, it's proven. No, it's certain. We don't know. The first year when I was using this question, I decided to do it just like a joke. And the answers I got was really interesting. And I stopped considering it as a joke. Let's see what you answer. Okay. So let's see what my students answer. So this is how I ask the question. So this is a compilation of the result over the last 2 years. There is life on Mars. 24% answer, yes, it's proven. When they arrive at the university to do science, I'm teaching to the students which are in chemistry, biology, and geology. They are together during the first year. So 1/4 thinks that's not believe, thinks that the science says there is life on Mars. And when I ask the second question, was there life on Mars? Almost half of them answer, yes, it's proven. Okay, the first year I thought, okay, maybe I'm teaching in a not that small, but in the suburb Paris university in Créteil. Maybe it's because of the public. So I asked the question when I was giving a seminar in a somehow prestigious school, a selective school of future biochemist engineers. No, what's first year? No, that's the. No, this is this year result. Yes, this is the highly selective and prestigious biochemistry school. So I have less answer, but well, there is life on Mars. 20%, yes, it's sure. There has been life on Mars. Roughly half says, yes, it's sure. I gave a conference in a sci-fi festival last year, and I asked the same question. There is life on Mars. Yes, it's certain, roughly 20%. There has been life on Mars. Yes, it's certain, half of the people are answering. And I had young... No, no, it's not the same. And last week, I gave a small outreach conference, and it was the same, always the same. And I'm not surprised anymore. I do it again and again, again and again. Of course, here I don't have that kind of answer. But if you ask this question, probably also around you, you might be surprised. And I think it might be a problem for astrobiology. Because if you want to get funding, if you want to get the public to support your science, if you want to get the money to go to Mars, if you want to get the money to bring samples back, because you say, yes, that's a key question. We want to know whether or not there's life out there if we are alone. If half of the people believe we know that. So if you get into the details, they would say, no, it's, yeah, but bacteria, it's not life. No, life is bacteria. Bacteria are living systems, are as complex as we are. But, of course, they know on Mars we haven't found dinosaurs, but they think, yes, bacteria are simple, so there's proof of life on Mars. And the only reason I have so far, so I'm an astrochemist, I'm not a sociologist, and I'm just doing random polls like that when I have the opportunity to do that. But my interpretation is astrobiowashing, the fact that we sell maybe too much of science, and it may backfire. It doesn't, because we have a lot of support, we get money, we have wonderful space missions, but it might backfire at some point. So, some examples. You know about the ocean worlds. When I was young, long time ago, so much younger than today, yes, when I was hearing about Enceladus, Europa, they were the icy moons of the giant planets. You probably learned about those moons, calling them icy moons. And even after a decade, we knew that Europa had most certainly an hidden ocean under its surface. It was still icy moons. But something like 10 years ago, didn't make the historical study, but it would be interesting to try to figure out when and who started to name those moons the ocean worlds. But this is all around the news. We have fantastic views like that of Europa, Enceladus. And sorry for the French, but it's a typical example of what happens. It was September 2016. It was 6 p.m. and Le Point, I take newspapers that are credible, that are a good reputation in France. Jupiter, the amazing announcement of NASA. The space agency may confirm the presence of an ocean on a moon of Jupiter, a discovery favorable to life. So this is before the announcement, because NASA issue an announcement saying we will communicate about a wonderful discovery. So the newspapers prepare the people, hey, there will be something fantastic. And yes, and since I'm not working on Europa, I don't have the advanced results, so I'm saying, yes, what are they going to announce? And this is 2 or 3 years after, in another newspaper, after the release, after the press release and the press conference, NASA has discovered possible geyser of water vapor on the moon of Jupiter. Possibles. Le Figaro is extremely prudent because they have journalists which are dedicated to science. And they always give a call before they publish. But it's not the case in all the journals. In many journals, the journalists that are doing the science papers, they do other things. They are not specialized necessarily in science. And again, of course, that discovery, if it's confirmed, might accredit the thesis according to which life could exist on this moon. And this is the press release, not the news, but the official statement of NASA. And they say, astronomers using NASA HST have imaged what may be vapor plume, maybe water vapor plume. They doesn't say it's water plume. It may be water plumes. And of course, Europa's ocean is considered to be one of the most promising places that could potentially harbor life in the solar system. There's never anything to say against an official NASA press release. They always put may, might, possible in the right place. You can never complain about that. But what is interesting is that it may be water. You're not even sure it's water. But it might be an incredible announcement. And, well, if you follow, like I do, that kind of announcement, you remember, well, but it's not the first time. And actually, in 2013, there was another press release saying that this time HST sees evidence of water vapor venting off Jupiter moon. So in 2016, it was nothing new. And it was just to say, oh, we see something, and in the end, we don't know what. And in 2013, yes, it was sure it was water vapor that was exhausted from Europa. And when you get to the papers, I just show you the abstract. Sometimes you have everything in the abstract. It's more interesting to read the details. But in the abstract of the 2016 paper, you can see that they measure absorption from gas or aerosol beyond the Europa limb. And the kind of measurement they do is, with that kind of measurement, they cannot say what it is. They say there's something. And they observe something. There's nothing to say against that. And yes, you have to publish if you see something getting out of Europa. It's very good science paper. And if you go to the 2013 paper, it's 2014 because in this final denomination, but it was advanced publication in December 2013. And then if you look at the data, it's actual identification of water vapor from Europa. So what was the point to make a press release and to make this media outreach in 2016 to say something that is, in the end, nothing new, which contains less information than in the previous detection, because you don't know what it is. You can tell it's water. Oh, it means that I have another question. For you. Yes. What are the requirements for life? Liquid water, organic matter, energy, all of the above? We don't know. Okay, let's see. Okay, most of you answer all of the above. So you agree with NASA. This is the web page of the Europa Clipper mission, and they explain why to go to Europa, and they say Europa has the ingredients essential for life, water, chemistry. Beyond chemistry, it's organic chemistry and energy. I would have answered, we don't know. That you probably need water, chemistry, and energy, but we have no idea whether or not it's enough to get life. And with all the news we have, these wonderful pictures we get. Europa is a water world. Is it inhabited? So they compare the Earth, Europa. They say there's more water than on Europa than on the Earth. They say Earth oceans are teeming with life. They say on Earth, wherever we find water, let's say liquid water, we find life. And you showed at high temperature it's not true. And Europa has twice the water on Earth, so is there life? Just, you see that everything is about liquid water and the comparison with the Earth. And so you find this. But in astrobiology, we are trying to show whether or not it's true. So it's not what I would call a requirement. We don't know. It's what I would call an axiom or a postulate. It's extremely useful. I mean, like a lot of people, I'm interested in those three parameters. But it doesn't mean that once you have those three guys together, you would necessarily get to life. But what is called an axiom or postulate, it's a statement that is so evident or well established. Here, in this case, it's more like well established, that evident, that it is accepted without controversy or question. Our job is to question that. Our job is to bring controversy to that. And maybe we will be able to prove it. I hope it will be that simple, and then, woo, there will be life everywhere. I hope we find life somewhere else. But there's no proof of that, and that's our job, to work on that. And this is one illustration. They removed it from the new Europa Clipper website, but this is the kind of illustration you would have found only a few years ago. And I like very much this paper that was written by John Sutherland. It was in 2017, so it's not that old. John Sutherland is, I think, but many others also think, is one of the best chemists working on prebiotic chemistry. He made major breakthrough in the way to conceive the origin of life. He didn't find the origin of life, but thanks to this guy, the perspective on the origin of life and the way to work in prebiotic chemistry has been changed a lot. And he published an opinion. It's not an actual paper, it's an opinion. It was published in Nature Review, and he called it Studies on the Origin of Life, the End of the Beginning. And he states that a requirement for ultraviolet irradiation to generate hydrated electrons would rule out deep sea environment. This, along with strong bioenergetic and structural arguments, suggests that the idea that life originated at vents should, like the vents themselves, remain in the deep bosom of the ocean, buried. He's quoting Shakespeare in the end. Maybe he's wrong, but what is interesting is the fact that among the people working on the roots of the organic chemistry that might lead to the first auto-replicative systems that could be at the origin of the evolution, the gray area between chemistry and biology, when it starts to replicate and evolve, something starts to replicate and evolve. It's not just an opinion, there are calculation, energetical consideration behind that. His conclusion and sharing with other people is that it's not possible to initiate this chemistry without photons. So it's worth to go to Europa. I don't say there's no life on Europa. I have no clue. I'm just saying that it's not that evident that because there is liquid water, organic chemistry, and even energy in the hydrothermal vents of Europa, that there would be life. But we have to go. We have to check. That's a fantastic perspective, but that's not that straightforward to say, well, wherever there's life on Earth, wherever there's water on Earth, there is life, so wherever there's liquid water somewhere else, there would be life. Oh, another one that I like. You probably have seen that. NASA predicts finding evidence of extraterrestrial life within 20 years. It was in 2014. Could we find alien life in 20 years? That's up for debate. La NASA nous promet des extraterrestres dans 20 ans. NASA is promising extraterrestrial life in 20 years. La NASA is giving, will discover alien life in 20 years. So, where does it come from? It comes from a press conference and a press release, and they were talking about the future James Webb Space Telescope and telling how cool, how a revolution it will be. And that's true, it's really a revolution in the way we see the universe. And the director of the institute said this, and again, it's perfect. Nothing is exaggerated when you read it carefully. He says, just imagine the moment when we find potential, signatures of life. Imagine the moment when the worlds wake up and the human race realize that its long loneliness in time and space may be over. The possibility we're no longer alone in the universe. How will you feel when you wake up in the morning and you hear, oh, we've detected something weird in the atmosphere of an exoplanet and it may be life? Will it change your way to perceive? Will it end your long loneliness in the universe and time? No, if it may. If you're not sure. And actually, it's what's going to happen. We will see weird stuff. And we will be unsure. And we will fight each other. And you will be probably in the generation of the people who will see that. It's a few years from now ahead of us. Because we will find something weird, unexpected. And what if you say, okay, within 20 years, we have to find the solution? What if, regarding the politics, the people who found you, you said within 20 years, we'll get you the results. And you start ticking the clock. What a few years before? What about a few months before the end of the 20 years? What about a few weeks before the end of the 20 years? Will it get you into some uncomfortable position? Well, probably those people saying in 20 years they will be retired. And for instance, yes, in 2017, this was 3 years after, it was still again within 20 years. And I would say again, if you give a number, they would say, oh, within 20 years. And so I have to, I want to finish on that. Because that kind of, we've already lived, I think, something which is similar to what is going to happen. Not regarding exoplanets, it's about Venus. It was 2 years ago, 2020, and well, in France, it was in the evening. I could start to see that kind of headlines. Life on Venus, astronomers see a signal in its cloud. A gas found on Earth that signifies life has been detected in the clouds on Venus. Venus shows signs of potential alien life in its clouds, scientists find. So this is, well, yes, I wanted to put the two sides. And this is in France. It's the same kind of headlines. And you also have the head of NASA at that time, the head of NASA tweeting, life on Venus, the discovery of phosphine, a byproduct of anaerobic biology, is the most significant development yet in building the case for life of Earth. Then he reminds that NASA discovered microbial life up there in the atmosphere. And he concludes it's time to prioritize Venus. It was right during the last few months of the selection of the next missions of NASA. And he was tweeting that. I mean, it's not a random scientist like I would do if on Twitter. It was the boss of NASA. And he was answering on a tweet of the Royal Astronomical Society saying, we have detected a gas called phosphine in the atmosphere of Venus. This could point to the presence of life in the clouds of Venus. This is the press release. Hints of life on Venus. It's not proof, it's hints. Okay, I agree. Why not? But they say on Earth, this gas is made only industrially or by microbes that thrive in oxygen-free environments. And then it attracts attention not because there is phosphine, it attracts attention on the fact that it might be a proof of life, and so it's time to go to Venus. But when you go to the paper, and by the way, the headline says NASA, 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 NASA. If you look at the list of the authors, most of them are English people. There are a few US scientists, but the leading part of the work is from England. So Nature Astronomy, so it's a good journal, peer-reviewed journal. So it has a good reputation. So it's not Nature, it's Nature Astronomy. Usually when you submit to Nature and they don't want you because it's not interesting enough, they suggest you to go to Nature Astronomy. And you start to see something weird. They don't say, we have detected phosphine. They say, here we report the apparent presence of phosphine. It's written in the bold-faced paragraph. It's apparent. It's not what they say in the press release. They say we have detected phosphine. So now let's discuss about the fact that it might be linked to life. No, in the paper they say it might be phosphine. And yes, of course, they say it could originate from unknown photochemistry or geochemistry because we barely know nothing about the atmosphere, the chemistry of the atmosphere of Venus for the trace gases, because it's a very specific kind of chemistry, high pressure, high temperature, weird composition compared to the kind of chemistry we know. Or, by analogy, with biological production of phosphine on Earth from the presence of life. And these are the detections. So here, what I learned when I was in school at the university was that to detect something new with spectroscopy, you need at least 2 bands at 2 different wavelengths. Then you have some start of a fingerprint that you can say this is this molecule and not another. they don't show two bands. They show the same thing with two different instruments, the GCMT and the ALMA telescopes. So that's not playing by the book, you know, for detection, at least a new detection, and a detection of something that is unexpected. You need at least two bands. But no, they have only one band. And you look at the signal. So this is a GCMT. So black and oranges are two extremes interpretation of the data, because Venus is very bright. And if you want to use those telescopes on Venus, which are built to very faint objects and faint environments, well, you get a lot, too much light. And you have a lot of data process. And the way you handle the data might give you different kind of interpretation. And these are two extremes, so the orange, so you don't see it much because, well, if you look only at the orange, you see nothing. I mean, it's a noise. And if you take a favorable way to interpret the data, you have the black. Well, it's a little bit above the noise, but you see just that tiny fraction of the spectrum. And what they do the average. And so you have something that is a little bit above the level noise. And here this is the ALMA data. And where is phosphine? Yes, phosphine is here. So this is the noise. And this is phosphine. Okay, why not? It's what probably the referee asked them to add, apparent detection. It's what I would call the tentative detection. But no, let's go to the front lines, let's make the news, let's make a press release. They are perfectly right to publish that. It says it's their duty to publish that. They say, okay, it might be phosphine, so let's publish that, so we will fight with other people who are going to say, we agree, we don't agree, but it will be a regular scientific open discussion. I don't complain on the fact that they publish in a peer-reviewed paper their result. But the press release, the press conference, maybe it's a step too far. And what is funny, let's call it like that, is that the day after, on September the 15th, MIT is publishing a press release saying that Breakthrough Initiative, which is a private association funded by billionaires paying scientists to do science and focusing on the question of finding life elsewhere among their main topics. And they publish that they just received a fund to study life in the clouds of Venus, the day right after the press release. So it's not during the night after the press conference that Breakthrough Initiative get to them and discuss, and we're going to fund them. It was necessarily something that was combined to make the news, to get a lot of news about and publicity about their project. And these people, most of them are in the list of the author of the first paper. Is there phosphine? I go quickly and I will finish about that. Well, it's a good thing to publish because then people will say, okay, if there's phosphine in the radio wavelength, there should be phosphine in the infrared. Let's look at the old data that we have in our database. And it was, so here we are mid-September. Here you are late September. This paper is submitted 2 weeks after the press release. And they put an upper limit at 5 ppb. So these are the data of phosphine, of Venus, data of Venus. And if there is phosphine, you should see this bump that should be added here. And they put an upper limit at 5 ppb, and here in their paper, they have 20 ppb. Then it was papers submitted mid-October, November, published in November. This team reanalyzed the ALMA data, and they say the detection is not statistically significant. They show they process the old data, and they made the calculation to say at what point you can say that it's significant or not. And the same thing for the GCMT data. One thing somehow comforts the detection of phosphine, to be honest. It's old measurements that were made in the early 80s by a mass spectrometer that was on board a spacecraft, a NASA spacecraft called Pioneer Venus. And they go back and dig back in those data while the spacecraft was getting into the cloud. And they say that there might be phosphine. These are the data. So it's old. These are old mass spectra. And you don't see peaks like I showed you before. It's only a few points that are measured at some specific scale range, because at that time the instrument could only do that. And okay, where is phosphine? Phosphine is here. Look. And at the same mass, you have H2S. They say it's better with phosphine than H2S. So you cannot rule out that phosphine is present. When I see so little data, I say I cannot rule out that phosphine is present. But it could be also H2S. And there is H2S. We know there's H2S from other means in the atmosphere of data. But now when you read the new papers of the team that claimed they have detected phosphine in the first time, they say that according to Mogul et al., this detection is confirmed by mass spectrometers of the Pioneer Venus mission. New data, new publication, late 2020, people go to the old data of the Venus Express, the European mission in the infrared. Okay, this is their measurement in the infrared. So if there is phosphine in the radio wavelength, there should be phosphine in the infrared. And look at that. So purple are the measurements. Blue is what it would show. It should show if there is indeed 20 ppb. You don't see phosphine in the infrared. But you still have papers, recent papers in 2022, that says more work is needed to reconcile all available phosphine data with a consistent profile of abundance by altitude. So this is the original team, less and less co-authors. You can see. And now, since there have been other teams showing that their data process was wrong, well, they still say it's there, but now they say, well, we highlight that abundances remain unknown due to the poor altitude information. So now they say we don't know how much, and we don't know where it is in the atmosphere. Well, the basics of the initial publication was it's in the cloud. In that kind of cloud, there is a small phase of liquid water, because considering the altitude and temperature. So since we see phosphine, then it could be bacteria in the clouds. And the amount of phosphine at that time was only, they interpreted it by life. So the current status is, they say there's still phosphine, but we don't know how much, we don't know where. And the most recent paper published was based on observation with SOFIA It's an instrument, it's in a plane, a stratospheric plane, then you get above the troposphere and you can make more precise infrared observation. And again, these are the data, and this is what phosphine should look like if you have 16 ppb, 1 ppb, and so there's no detection in the infrared. Look here, it's easier to see here on this part. The red is 4 ppb. There's no sign of phosphine. And here you see again the first data that were used and the evolution of those data over time. So this was the first publication here in the GCMT data, and other interpretations that has been done by other teams. These are the same data, not this one, GCMT, but these are all ALMA data. The interpretation by Greaves et al. And the interpretation by various independent teams based on the same set of data. As I said, it's right to publish. It's right to publish even though you have a doubt, because sometimes publishing something with a doubt will help you to lift the doubt, because more people will get attracted and get the information and will work against you, with you. Well, doesn't mean anything. They will do science. But in the end, this detection that was claimed to be the most significant development yet in building the case for life of Earth is there. Well, did you hear about the first paper in 2020 about phosphine detection? Who heard about it? Yeah. Who read this one, for instance? Who heard about it? Yeah? Yeah. But less and less people, of course, because we are scientists. The people not doing science, the people not working in the field of atmosphere of Venus, of astrochemistry or astrobiology, they will never hear about that. They will remain on the fact that there might be life on Venus, and it depends the kind of newspaper you read, because sometimes the might, may, the question mark is dropped. So I think I have to finish. Just to say that it's our responsibility to make astrobiology a field that remains credible, and well, we have to pay attention. It's our own ethics, and I know that there can be some tension. You know, if you have a press release, either if you are director of institute, or if you are a young scientist, or if you are the president of a university or a laboratory, you have to show off a little bit, always. And you have to keep your ethics at a high level, because, as I said, I think the consequence of such behavior is the fact that average, not in a bad sense, but non-scientist people, and also people not in the field, think, roughly half of them think we already settled the question of life elsewhere. Thank you.
Thank you, Hervé, for this very nice talk. So, questions?
Can we see the results of the poll you submitted us to? The real results?
You mean to my students?
No, our results.
Oh, yours. Well,
What was the final answer? About life on Mars, say.
There is life on Mars is here. So 2
people believe it's proven. 4 people believe there has been life on Mars as a
Right.
proven instance.
You always have to pay attention to the fact that some people might answer in a provocative way just to joke. So
Okay.
for me 2 or 4 is not
They
significant.
shouldn't, but
Yes, but what I do with my students first, well, look, actually I didn't thought about that, but it's actually what I did. I start with that kind of stuff. You know what? Where it's not a big matter to answer with a joke. No, someone answer Qatar. I think it was.
it's not credible, yeah.
It's maybe they will win, but I wouldn't bet. I would not bet on that. And I start my class. They see me for the first time, so I always start my class asking in which formation you are. So I propose the correct answer, and I always put something like a PhD in medicine. And so I see that in the 150, 200 people, I see, okay, there are 3 or 5 people that answer they are in PhDs in medicine, and so it gives me the kind of feeling of, yes, the amount of people who will answer as with jokes, and then. Yes, you see, it's really the first time. Before I was using another tool. The first time I thought, yes, it's a concours de circonstances. It's just a one-time result, and then I say, okay, maybe my wording was not correct, and then I pay much more attention to the way I was asking the question, saying, okay, what does the science say? What you think is the current status of science on this question? And then just, it's only 2 years ago that I had the idea to add the question whether or not there was life on Mars, and not there is life on Mars. And then you get 50% almost, and everywhere.
One of the things that when I'm talking in a similar vein as you just did, I tell my students that as scientists we never prove anything. We find evidence for it, and more evidence and more evidence. Mathematicians sometimes prove things, but scientists never do. But you use the word prove in a scientific context many times, so I'd like to tell you shouldn't do that. That just in the vein of being more skeptical about it.
No, but I agree that I am at a point that I think I should now work with people doing sociology studies, constructed sociology studies, and not an astrochemist. Yes.
But as an astrochemist, you've never proved anything. As an astrophysicist, I've never proved anything. We've gathered evidence, good evidence. Oh, this is really good evidence, but never proved.
Well, detection of some molecules, sometimes you can prove it. I mean,
you're putting things in a way that people expect you. They are not epistemology experts. So you are trying to, say, follow the manner in which they would frame the question themselves. General people think about proof. Of course, you're right, Charles, of course. But then if you go into too much detail on the epistemology of the thing, he misses his point. So he's not doing his pool. So I think you're right.
So you're right, too, of course. Oh, we're both right. Okay. The other thing is I've spent a lot of time trying to deconstruct the word life. And you've used life a lot as if we knew what it was.
Yeah, but it's... I agree that life is a very complicated and probably sophisticated concept. But I'm talking to my students.
So you just accept the conventional definition that they have in the back of their heads?
Yes.
Okay.
They are here, they are smart, they are very nice, I like them, but yes, and during my last lecture, I asked again the question. And then I have 2 or 3 answering, yes, it's proven, but I think those are the 2 or 3 that are answering by joking. But yes, I would completely lose them if I start to discuss the subtleties of what is life.
I think Molly wants to criticize my critique of you.
I was just going to say that in law, we have big debates over what pornography is, but a justice of the U.S. Supreme Court said, pornography? I know it when I see it.
Yeah.
That's what your students do with life.
Another question?
That was actually an interesting point. That was a hardcore pornography over the movie Le Mans, right? So my question to you, everyone, is the following. With respect to the inability of the general public and the non-specialists to actually absorb and process information, very scientific, what's your suggestion to improve that? And before you answer, this guy called Yuval Harari, that I'm sure you know, predicted that reliable information nowadays in the near future is going to have to be paid because free information has too much noise.
I don't know. I don't know what to do. I mean, but I think it starts with us as scientists. Sometimes I hear colleagues saying, oh, journalists. No. The press release, I've been associated to press releases. We have our words to say. Sometimes we are writing them. So it's our responsibility. I remember when glycine has been discovered by Rosetta. I was in the team, and I co-authored the paper. I read the first draft of the press release, and it was, oh, glycine, oh, life. And okay, and I was saying, oh, and actually I answered, okay, it could be, we should add some cautions to the wording, and I've suggested to add, there's a huge gap between glycine and life and a lot of unknown within this gap, and I don't remember exactly the wording, but I was quite happy because they accepted my correction, and it's been included in the press release. So we have to pay attention, and I really think it starts with us. For the phosphine, I mean, it's just the fact that the day after their big announcement, they announced that they have a funding from Breakthrough Initiative, which is a private association. Yes, there is an orchestration. I'm not a fan of complot theory. Conspiracy, yes, thank you. I'm not big fan. I'm not seeing that everywhere, but there is an orchestration behind that. And Janet was talking about money and power. Well, there is money here, and there is power, because after that, you have 2 missions for Venus that has been selected by NASA, and 1 also by ESA. So the 3 missions have been selected within the few months after this announcement. And actually, those missions are not looking for life. They are extremely good missions. They are studying Venus. They are studying the environment of Venus. We are going to learn a lot about Venus.
When you say an orchestration, what do you mean? What do you mean by orchestration? What do you mean by orchestration?
What?
When you say orchestration, what do you mean? What do you mean by orchestration? 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 What do you mean by orch
I think it. You know, if you sit in the committee and if the boss of NASA says he wrote it's time to go to Venus, he wrote it. Well, at least. Well, what do you choose? And it's. I agree. It was time to go to Venus. It's been so long we've not been to Venus. It's an amazing planet. But why should we have to sell it from an astrobiological perspective to go there? It seems that to do anything now, you need to put it some fancy astrobiology stuff in it. And maybe, yes, 3 missions at the same time, maybe it's a bit too much, maybe 1 or 2 should have been enough, I don't know, but yes, correlation doesn't mean that it's a consequence, I know about that, but well, it was hard not to decide to go to Venus after such a mess. Yes?
Yeah, communicating science, I think it's very, very important, and it may become a trap if you don't do it the correct way. So if we scientists leave to other people to accomplish this task, it may be very how can I say, it may be negative, because people in general, people love science. People always have some questions about science. So if you give them the wrong answers, and they believe in the wrong answers, and they don't understand the scientific method and everything, so it may become a trap. So I agree with you, it's our responsibility to communicate science in the best way we can do it. So it's very important.
Because maybe there's phosphine on Venus. Why not? I mean, it's pH 3. And it's funny to say that you've probably heard about claims that there might be life on Mars because of methane, CH4. You know, you try to find a signature of life in some of the simplest molecules. CH4, pH 3, O2. It might be linked, of course, but to give what you would call the biosignature, I mean, that's a signature. It's a proof of life. I think it's not enough. And this is this detection, phosphine, I think it's a good school case of what is necessarily going to happen in the coming years with the observation of the composition of the extrasolar, of the exoplanets' atmospheres. Because we will be at the limits of our detection. If you're doing your science, you're always doing it at the limit if you're the first to discover something. So you see something popping up in the noise of your instrument. So you need to know your instrument. You need to know how to process the data. And yes, and then you say, okay, if it's really there, if, let's say, oxygen in the atmosphere of an extrasolar planet, telluric extrasolar planet in an habitable zone, we will detect at some point, for sure, oxygen in the atmosphere of an exoplanet in the habitable zone. Well, will we claim that we have detected life? Yeah, but first you have to question the detection, because it probably, the first will be probably depending on how you handle the data. And then you have all those people who are working on the modeling of the atmosphere of exoplanets who show that they can synthesize O2 without any life. It depends on the kind of radiation of the star. It depends on the state of the surface of the planet. It depends on many parameters. And I think this quote is wonderful. The what of Matt Mountain. Potential. Our loneliness may be over. The possibility. We will be facing that. We will see something weird and we will have to publish, because after publishing, people will question your detection. If it's that important, people will question that. And people will tear the data into pieces and try to prove you wrong. But that's the way it should be. So when do you make the announcement? When do you make the press release? When you publish your detection, your tentative detection, your attempt of detection, the apparent presence of your molecule, or 6 months, 2 years, 10 years after, when things have settled down and you are quite confident it's there. I don't know what I would do.
The abstract of the Greaves et al. Paper wasn't bad.
What?
The abstract of the Greaves et al. Paper 2020 about phosphine, the abstract of the paper was not bad.
No.
But it was okay, it was scientific.
Yes,
they use the right words.
The abstract is okay, but
okay.
when you read the paper carefully, you see that in many places they dropped the tentative or apparent detection. In many places they say, okay, we detect an abundance of 20 ppb.
They should have kept this skeptical language.
It looks, for me, but I'm reading it, it looks like, okay, they published something very optimistic, and then at least one of the referees said, no, you cannot say that. You should correct, and then you can still find some sentences and formulation of the original paper that missed the necessary caution.
So you have two problems here. One is the people want attention. That's a human trait.
Yeah.
In science, we need to publish. So you want to publish spectral results. So it's very common that you read the paper as a referee, and you see that the authors are trying to push something that's really not in the data. They go to the more sensational thing, the thing that grab attention. So you have to dive them down a bit and get a good paper. That's a process, all right. But the thing is, when you go to the public, they don't know that this thing we do is an ongoing process that never really ends. So maybe that's a problem. Maybe you should try to communicate that, okay, you have this result now that might be interesting, but this is an ongoing debate. It doesn't end here. Because when you go to life, I recall I guess there are at least two major announcements of detection of life. You have the Viking experiment, and then you have the Martian meteorite.
Yeah.
I guess Clinton was involved in the press release. So, and the people that gets this news and don't know that these things are going to debate, then they know their life on Mars. So maybe that's why you get these answers that people that think there's life on Mars, or think there has been life on Mars, because there was an announcement some time ago that involved the president of the United States and said so.
Yeah, and I found actually I had a hard time to find the actual the movie of Clinton making his statement. I have it on my hard drive, and it is extremely careful. He says this discovery, if confirmed, and then the remaining. So when you read you read what he said, you say, okay, he was careful. It has not been confirmed, but yes, well, if it's in the details, and the fact that people will only remember what was in the news, and it's very complicated to yes, to get the people understanding the way we work. COVID was a wonderful example. I mean, I think during COVID, at least in France, people could have this beginning of a perspective of what is research. Because we have a theory, we think, oh, hydroxychloroquine might be a cure based on one publication, probably falsified publication, and then, well, it takes time for the other publication to come and to contradict and prove that the first publication was wrong. And it was like, an ongoing investigation, and we were hearing about this COVID. We are learning every day, every week, new things that sometimes were contradicted later. So I don't know if there will be a lesson learned in the public from this, because they want us as scientists, they want us to know, to be sure, and I think it might come from the way we teach science. You start when you, and it's a difference. There is a difference between research and when you teach science in high school. No, in high school you have a problem. You will have a grade, and your grade will depend whether you get the right or the answer right. That's how people learn science. And that makes sometimes people hate science because of this matter of right or wrong. Calculation, yes, it's right or wrong. Even a chemistry or physics problem, it's right or wrong. And then at some point, and you are beginning to experience that, at some point, well, we don't know. That's the fun, actually. I would not enjoy to do pH measurements all my life, calculating pH. But we probably not, there's probably not enough research and outreach about the science methodology in the media.
Okay, the discussion is very interesting, but we have coffee break now. Okay, so, but before you leave, this is the last lecture of Dr. Hervé Cottin. So, Hervé, thank you so much for this very nice course, and be welcome to come back. Okay.
Yes, it's been really a pleasure to talk to you, and I'm still here, and we can still discuss on these topics. Thanks.
Okay.